This time, we're going to add a couple of ideas to section 4.5, solving word problems using systems. And so these are additional problems. They are called revenue and cost problems and finding the break-even point. So I have an example from your textbook that shows a graphical representation. R of x, and that is just a special name for letter y, is a revenue function, and that is money in to a business. That's money that you bring in. C of x, which is just another y, is the cost function. That is money you spend in a business to make whatever it is you're selling. So if you look at this graph, here's your revenue. If you don't make any and sell them, you don't bring any money in. And then the more you make and sell, the higher your revenue. Now, the C function, which is the cost function, you have a cost even if you don't sell any because you had to make them. Maybe you had to pay electricity, you had to pay rent, even if you didn't make and sell any. As you make them, all of your expenses increase and your cost increases. So every point on this line has an X and a Y because I am going to call these Y's. So this point would represent, if you had, I'm just going to guess, that's about 600 packages of stationery made, it would it would bring in over $3,000. When you made this 600 packages of stationery, it would cost you maybe more like $4,700. So that's a bad situation. It's a bad situation when your cost is higher up than your revenue. Now, both of these are increasing, but you can see that right here, the revenue and the cost are equal. So when you make and sell about 1,200 packages of stationery, the money you spend and the money that you bring in are both $6,600. So it is 1,200 packages of stationery and it is $660. That's when you break even. In the financial world, you would rather be in this scenario because the revenue, the blue one, is higher up than the cost. All right, now I gave you that whole background, but solving these problems is really not going to be that challenging. All right, here is an example. These will be in your homework. And it says, given the cost function, now even though it says C of x, I'm changing it to y. Y is equal to 73x plus 87,000. And then I have a revenue function, but I'm calling that y also. Y is equal to 148 times x. All right, x is the number of units and y is the money made or paid, depending if it's revenue you made it and if it is the cost function you paid it. All right, all of that aside, I have a system. What technique am I going to use? Well, graphing's very good, but it is the most tedious. To me, when you do cost and revenue functions, substitution is virtually always the easiest way. I'm going to circle this it's equal to y, and I'm going to take it and put it in the place of y. So I have 148x is equal to 73x plus 87,000. Let me get just a little more workspace. All right, I'm going to subtract 73x from both sides. That gives me 75x is equal to, that's gone, 87,000. Off screen, I'm grabbing a calculator. 87,000 divided by 75. So I divide by 75, I divide by 75, and I get x is equal to 1160. This is number of units for break even. When that's all the question asks for, you do not have to go on and find y. Y would be the amount of money associated with that, but that is not part of the question, so all we'll do is get 1160 units must be sold. Let's try this again. Here's another example. I have a cost function, but I will call it y is equal to 1.4x plus 1200. And I have a revenue function. I will also call it y equals 1.5x. X will be the number of units, and y will be the money. So how am I going to solve this system? Well, I'm going to use substitution again. This is an easy expression for y. I'm going to put it in the place of y. So I have 1.5x is equal to 1.4x plus 1200. Now, if you want to, you can get rid of all the decimals, but I really don't mind decimals. So I'm going to subtract 1.4x from both sides. That gives me 0.1x is equal to 1200. I'm going to divide by 0.1, divide by 0.1, and x is equal to 12,000. You need to sell 12,000 units in order to break even. So hopefully you agree that break even is not going to be that challenging. And let me put that in there. So this one type of problem where you've got two examples can be added to your knowledge from the other lesson video, from the rest of the lesson video, and I think you've got solving systems in application problems.